At an 8 kilogram wooden block is attached to a 2 kg wooden block by means of a weightless inelastic string which passes over a frictionless pulley. The block accelerates down a rough plane inclined 20 degrees to horizontal as shown in the diagram below. Right now, the tension in the string is 21 newtons. So, roughly 21 newtons as the tension on the string. Right. Define the term acceleration. This is just the rate of change, in velocity but we can say the change in velocity per unit time. Right. So we know that acceleration equals to change in v over change in t. So that is rate of change in velocity. That's what we have. Draw a label free body diagram of all forces acting on the 8 kilogram block. Right, so you go draw a free body diagram. So you draw the sloping like this. Then we have our object as this dot. All the forces that are acting. How many marks? That's about 3. So we 3 forces the action. So rolling normal force, and then definition of normal force area. Normal force is force exerted by the surface and act perpendicular to the surface. So this must be perpendicular to the surface. Then we have a tension that is acting parallel surface, and then we have force to gravity, and then that's what we have. They said frictionless pulley. Then what about the friction on the surface? Right, so it means there must also be a friction that is acting in that direction, the frictional force. Right, this is what we have. Free body diagram. Now they say prove using a calculation that the magnitude of the acceleration on the system is 0,7 meters per second squared. Right, the acceleration of system. Alright, if it's acceleration here 2 kilogram block, then there is one acceleration here 8 kilogram block, because this one is string system. So rolling so come a free body diagram here 2 kilogram block. So the free body diagram, we're going to have this overlay F tension, and then overlay FG. Namile running subject to sign convention. So we're going to say for this part, of course, running the acceleration, the object is a mover in that direction. So normally the direction I go object yang or positive. So running, we're going to take up as positive. So we need to take up as positive. So if that is the case, rolling that's why Newton's lowering F net equals to MA. Then if F net equals to MA, but F net again, the first the acting on this object, I shumisha free diagram, so I want to pedi, and then they are acting in opposite direction. So ka baka la object e tla be move vertical, so ra tlo shumisha tsona tse di tsamayang vertical. So ra ro ba leng mo F net rena ra ro ba le FG ya fase, ra it's going to be negative. So ra re kana reng F of tension minus mg, or get the force due to gravity, equals to ma. Right, from here now let the tension, what tension, that case we're over 21 minus the mass, mass 2 multiplied by 9.8, and then equals to mass 2 multiplied by A. Right, I'll press a calculator on this other side. We're going to have 21 minus 2 multiplied by 9.8. So about again 1,4 equals to 2a. So divide both sides, 2. So divide 2 divide 2. So vale 0,7 meters per second squared equals to a. I mean the acceleration like this one. Now if I calculate the magnitude, so magnitude only need the size of the frictional force experienced by 8 kilogram block acting on this. So average frictional force on 8 kilogram. We draw a free body diagram. So range all the forces action. So forces vertical to the vertical perpendicular the surface, which is this surface, or even parallel to the surface. So but in this case, because object mover in this direction, it mover parallel to the surface, so roger force among parallel to the surface fair. So our level mo re tlo tlhatlhamala this FG. So re tlhatlhamala or ebe le parallel to the surface, so ra reng e ngwe swantse tle mo e tswa ka di component tse pedi ebe FG parallel, which is elegant mg sin theta, and then engwe keng e tlo ba perpendicular to the surface ya ba FG perpendicular. So ka metlha di le jwalo, as long as re na le a slope with angle theta. Right, so ra force di acting horizontal to the surface, so ke tsona tše di le 3. So ke tension, ke friction, then this one. So the direction sign convention, because object ya ya downwards, so here downwards we are going to say down, take down as a positive. So I'll take it downwards will be positive, then everything that is going up the incline negative. So that's all. If F net equals to MA. Now F net are force the acting on this one, the acting horizontally to the surface. Our object mover horizontal to the surface. Tension we are minus tension, then frictional force now over minus frictional force, and then FG parallel, which is mg sin theta, we are fast down the incline, we have positive mg sin theta equals to because acceleration ka kana e nyaka direction but re choose e ya fase, then ra reng e tlo ba positive a. mme re substitute ba rile tension ke bokae, minus 21, and then frictional force ke ba e nyakang minus the frictional force, plus mass ke bokae is 8 kilogram, and then 9.8, and then sine of angular ke bokae is 20 degrees, equals to the mass is 8 multiplied by acceleration ya rena re ikhumana mo 0.7. right, o tloa mo gore re ka no tšea this all numbers ra iša ka mo, or a re tšee mo ke bereka ka algebra, gore re ka no tšea positive, I mean motho o re nyaka mo solver ke a re beletše mo re nyaka solver this one, so ka re ke negative re mo iša on the other side, so wa re mo shifter a etle ka mo ra reng o ba le equals to, ra re o ba ka mo o ba le positive frictional force, then ka mo ra re o ba le minus 21 plus 8 multiplied by 9.8 multiplied by sine of 20 degrees, then ye e ba minus 8 multiplied by 0.7. amile on the calculator, minus 21 plus 8 multiplied by 9.8 multiplied by sine 20 minus 8 multiplied by 0.7. so the frictional force in this case is 0.21 newtons. So the frictional force that is acting on the object.